Every time you unwrap a chocolate bar, whether it's Cadbury, Hershey's, or Lindt, there's something inside that the company doesn't put on the label. Two things, actually. The first is a government allowance. Under U.S. law, every bar of chocolate you've ever eaten is legally permitted to contain a measurable amount of insect fragments and rodent hair. It is written into the official FDA rulebook. The second is worse. In 2022, Consumer Reports tested 28 brands of dark chocolate from major manufacturers. Every single one contained lead. Every single one contained cadmium. Not some, all of them. We'll reveal the official FDA insect limit and explain how heavy metals end up in your chocolate by the end of this video. And both answers will change how you see this product forever. Every product has a secret. We go inside the factory to find it. Wheezy, Belgium, home to the Barry Callebaut plant, the largest chocolate factory on Earth. This single building supplies countless brands you see on the shelf. It is a city of chocolate. Here, raw, bitter beans are subjected to extreme heat, immense pressure, and microscopic tolerances. This is the complete story of how chocolate is really made. For most of human history, chocolate was something you drank. In Mesoamerica, Theobroma cacao was a bitter spiced beverage reserved for the elite. The Aztecs valued it so much that cacao beans were used as literal currency. You could buy a turkey for 100 beans. When Spanish traders brought it to Europe in the 1500s, it remained a luxury drink for 300 years. Then, in 1828, a Dutch chemist named Coenraad Johannes van Houten changed everything. He patented a hydraulic press that squeezed the fat, the cocoa butter, out of roasted beans. This yielded dry cocoa powder and a massive surplus of butter. 19 years later, the English firm J.S. Fry & Sons decided to recombine that powder and sugar with the extra cocoa butter. The result was a moldable paste that set into the first solid chocolate bar, but it was gritty, acidic, barely edible. The fix came by accident in 1879. In Switzerland, Rudolf Lindt left a mixing machine running over the entire weekend. He forgot about it. When he came back on Monday morning, the coarse, sour paste had transformed into something smooth and melting. That accident, 72 hours of continuous shearing and aeration, became the process he called conching. It remains the backbone of chocolate production to this day. The supply chain from bean to bar takes about 2 to 4 weeks. Most of that happens before a bean ever sees a factory. Step 1. Harvesting. Cacao pods don't grow on neat bushes. They sprout directly from the trunk and thick branches of the Theobroma cacao tree. Workers cut them by hand with machetes. One wrong strike damages the flower cushion on the bark, and a pod will never grow there again. This is the only step in the entire chocolate manufacturing process that cannot be automated. No machine has been invented that can harvest cacao without destroying the tree. Inside the opened pods are 30 to 50 wet beans covered in a thick white pulp. Step 2. Fermentation. Farmers pile the beans into wooden boxes and cover them with banana leaves for 5 to 7 days. Microorganisms take over. Yeasts consume the pulp sugars and create ethanol. Then bacteria convert that ethanol into acetic acid, driving the pile's temperature up to 50 degrees Celsius. That heat kills the bean's embryo and builds the exact chemical precursors for chocolate flavor. If this step is cut short, the beans remain purple and bitter. No amount of factory processing can fix under-fermented beans. Step 3. Drying. The fermented beans spread onto raised beds to dry under the sun for a week. Their moisture drops from 60% down to 7%. They need to be bone dry to survive the long ocean cargo routes to Europe and America without growing mold. But here is where the first contamination enters the chain. Open-air drying in the tropics means the beans are exposed to dust, soil particles, and airborne lead from nearby industrial activity and vehicle exhaust. The shells absorb it. This is the beginning of how heavy metals get into your chocolate, and it is not the factory's fault. Step 4. Roasting and winnowing. Inside the factory, the beans hit massive rotating roasters. They tumble for 20 to 40 minutes at up to 140 degrees Celsius. The heat drives the Maillard reaction, developing over 600 flavor compounds, and it sterilizes the raw crop after a long journey from the tropics. Machines crack the beans open and winnow the pieces, using high-velocity air to blow the light, papery shells away from the heavy core, the cocoa nibs. The FDA limits shell content in finished products to less than 1.75% by weight. That shell fraction matters. It is where the lead concentrates. Removing shells removes most of the surface contamination, but not all of it. If you're still watching this, you're exactly the kind of person this channel is built for. People who want the real story, not the factory tour version. Hit subscribe and let's get back inside. Step 5. Grinding. Solid becomes liquid. The nibs enter a heavy mill where immense pressure and friction grind them down. The heat melts the internal cocoa butter, collapsing the mass into a thick, dark fluid called chocolate liquor. But microscopically, it's rough. It moves to a 5-roll refiner. This unit uses massive steel rollers, each spinning slightly faster than the last, to squeeze the liquor into a razor-thin film. The target particle size is between 10 and 30 microns. A human hair is 70. Anything larger than 30, and your tongue registers it as grit. This is where the factory adapts to you. Japanese consumers demand a particle size around 10 microns. Europeans expect 12 to 25. American chocolate runs closer to 30. Engineers adjust the refiner tolerances for each country. Every chocolate bar you have ever eaten had its texture calculated down to the micrometer. You just couldn't feel it. Step 6. Conching. Lint's accident, now scaled up to industrial scale. The refined flakes enter a conchi. For 4 to 24 hours, heavy paddles shear and mix the chocolate at temperatures between 49 and 82 degrees Celsius. The friction drives off the sharp, acidic notes from fermentation and aggressively coats every solid particle in fat. Milk chocolate conches at the lower end, around 4 to 12 hours. Dark chocolate at the higher end, sometimes up to 72 hours for premium grades. Underconked chocolate tastes sour and chalky. The factory fixes it by extending the conch time or adding a small amount of cocoa butter to improve flow. Now, here is something the chocolate industry does not want to explain. If you have ever eaten a Hershey's bar and noticed a slight tang, almost sour, almost like vomit, that is not your imagination. Hershey's uses a process called lipolysis on the milk in their chocolate. This breaks down the milk fat into free fatty acids, including butyric acid. Butyric acid is the same compound the human body produces during digestion. It is literally what gives vomit its smell. Hershey's has been doing this since World War II because it extends shelf life. Most of the world finds this flavor repulsive. Americans grew up with it. You are not eating spoiled chocolate. You are eating chocolate made with a process the rest of the planet abandoned. Step 7. Tempering. The liquid chocolate must be cooled and heated in a precise sequence. The goal is to force the cocoa butter to crystallize into its most stable structure, called form V. Cocoa butter is a fat that can solidify into 6 different crystal structures, labeled form Y through form 6. Forms I through IV are unstable. Chocolate made with them is soft, crumbles, and develops a chalky white film called fat bloom. Form 6 is rock hard and takes weeks to form. But form V is exactly what the factory wants. It melts just below human body temperature. The molecules pack together in tight, orderly grids. That density creates the glossy sheen and the sharp snap when you break a bar in half. A modern Solish turbo temper unit processes 8,000 kilograms an hour. It heats the batch to 45 degrees to erase all crystal memory, cools it to 27 degrees to trigger new crystal growth, then abruptly heats it back to 31 degrees. That spike melts away the unstable crystals, leaving only form V seeds. Workers test the temper every 30 minutes. They watch a digital display for a perfect cooling curve. That reading dictates whether your bar will shine or bloom. Whoa! Step 8. Molding and packaging. The tempered chocolate drops into polycarbonate molds. Heavy vibrations shake out the air bubbles before the molds enter the cooling tunnels. Robotic arms grab the finished bars and slam them onto wrapping lines moving at hundreds of units per minute. Now the lead question. Okay, Consumer Reports found heavy metals in every dark chocolate bar they tested. The lead comes from the drying stage, when beans sit in the open tropics near contaminated soil and exhaust. The cadmium comes from the soil itself, absorbed by the cacao tree's roots deep in the volcanic earth of West Africa and South America. Dark chocolate is worse because it contains a higher concentration of cocoa solids, which is where both metals accumulate. Milk chocolate dilutes the solids with milk fat and sugar. The industry knows this. The FDA knows this. But there is no federal limit for lead or cadmium in chocolate. California's Prop 65 requires warning labels, and most major brands have been sued under it. If you eat 1 or 2 squares a day, the risk is minimal. If you eat a full bar daily, you are accumulating lead at levels that medical professionals consider concerning, and the insect limit. The FDA's Food Defect Levels Handbook states that chocolate and chocolate liquor can contain an average of 60 insect fragments per 100 grams. That same 100-gram batch is permitted to hold an average of 1 rodent hair. A standard Hershey's bar weighs 43 grams. The government knows it's physically impossible to harvest a tropical jungle crop without natural contamination. So they set a legal ceiling for what they call unavoidable defects. Companies aren't adding pests to the vats. The raw beans arrive with them. The roasting and winnowing remove most of it, but the law outlines exactly how much debris is permitted in the finished bar. One last thing. If you eat white chocolate, you are not eating chocolate at all. White chocolate contains 0 cocoa solids. It is made from cocoa butter, sugar, and milk. The part of the bean that carries flavor, color, and antioxidants is entirely absent. In the United States, the FDA does have a standard of identity for white chocolate, but it requires only 20% cocoa butter and no cocoa solids whatsoever. You are eating sweetened fat with the name chocolate on the wrapper. The global chocolate industry is worth $31.87 billion. It runs on a supply chain that begins with hand-cut pods in Ghana and Côte d'Ivoire, where over 70% of the world's cocoa is grown, much of it by children. It moves through open-air drying that contaminates the beans with lead. It passes through industrial conches and tempering lines that calculate texture down to the micrometer. And it ends in a wrapper that tells you none of this. Every bar on the shelf carries the same math. The same 7% moisture, the same Form V crystals, the same legal allowance for insect fragments, the same trace metals from volcanic soil. This is not a scandal. It is the raw physical reality of turning a tropical crop into a global commodity. If you want more videos like this, the real story behind the products you use every day, hit subscribe. We go inside the factory so you don't